Okay, welcome everyone to this online course. It's going to be presented by Steve Dowie, who's down there in Adelaide.
Not quite. Melbourne.
In Melbourne, sorry, yes. And I'll just say a few words about Steve. Steve completed his PhD at the University of Hull in 1999, and the title of his PhD thesis, and I've got it here, was Advanced Online and Offline Process Control for Surface Engineered Applications. So you could say that Steve was way ahead of his time, and as always, and incidentally, he did his first degree at Hull, as did his wife Sue, in a new department there called Engineering, Design and Manufacture, which was a very innovative department that was set up to mirror the findings of the Finiston report that said engineering should be taught from a design perspective. And as I said, it was the first one of the kind, and I think that was a prelude to everything that we've achieved really since then. We also set up the Research Centre of Surface Engineering there, and we established a laboratory for surface engineering in 1982 there, which I think was probably the first in the world with that title. So that's the background to Steve, and not going to waste any more time. I'm going to pass over to Steve. Over to you, Steve.
Well, thank you, Alan, for that kind introduction. So today, well, this is really the first of three presentations or workshops on the Smart Enough Factory, and the title of the presentation is Achieving Low Cost, Low Skill, Low Risk Industry 4.0. Well, by the way, I should maybe introduce myself as well. I'm the technology manager at Sutton Tools. I'm an industry fellow at RMIT, and I'm also the founder of the Smart Enough Factory company. So let's move on. Let's make sure I've got my mouse in the right place. Well, there's a subtitle to this, and it's How to Nail Jelly to the Wall. If you took and you looked at the title there, low cost, low skill, and low risk, all those things are very difficult. And if you start off with, well, let's say proper jelly, no matter how many nails you put in, unfortunately, it slides off and it doesn't stick. What you need to do is you need to change your jelly. You need extra gloopy ballistic jelly. So potentially, this is really what I have to say, that if you want to achieve those aims of low cost, low skill, and low risk, it's going to mean that we have to make some very deliberate choices. So without further ado, I'm going to give you some context here. So let's there's some links there if you want to find out about nailing jelly to a piece of wood. These people have done it. Anyway, I love acronyms. This is the too long didn't read version of the talk. Now, I heard recently, well, not too recently, but a little while ago, that you can always tell a Yorkshireman, but you can't tell him much. I was quite offended when I heard that, to be quite honest, but there we go. I think a few people might agree with that. The point is that in 2020, even software and frameworks have opinions. And that's pretty important to understand. And again, these are just some summary points that digitalization, that's really the key to start your Industry 4.0 sort of solution journey. And you need a strategy, a goal. And we're talking about OT and IT. Now, if everyone's familiar or not familiar with OT, it's operational technology. And I heard a definition of that, and it's essentially IT for the non-carpeted areas. But we need a strategy for Industry 4.0 and digitalization. So I'm going to show you in the course of the workshops, a pattern that you might want to follow. And it is a pattern. It's not a prescription, but it's showing you how to adopt Industry 4.0 to achieve those aims. And if you want to copy it, it's there, just like any pattern as normal would be. But the point that I really want to make as well is that you have to understand the digitalization of your process. And that's the key to Industry 4.0 for your company. And what I want to say there is that you need to get opinionated too. So let's start. Why do we need a smart enough factory? So what's wrong with the smart factory? Because we've all heard of the smart factory and we see these flashy videos of them and what the big players are offering. And what does smart enough mean in this context? So Oh, look, this is a very old slide, actually. It's about 5 years old now, but there's one thing about this slide that I want to, well, maybe two things, actually. Of course, is that great big dollar sign on the right-hand side. That's why Industry 4.0 is attractive. But if we look here, this is by business. And if we look at this machinery section in mechanical engineering, potentially here, this bar on the right indicates that the essential benefits to industry in this region are about the highest in all the different types of industries that they've selected. And this, of course, is talking about Germany, but this is 2015. But machinery manufacture is an area where there's low automation and potentially where the biggest benefits are to productivity. And so it's productivity is what the focus of Industry 4 was at that point. That's 2015. Let's move on to 2017. Industry 4.0 is not being adopted. And there's a quote here. In many cases, the faltering implementation of Industry 4 is due to rigid organizational structures that have grown up organically and a conservative culture where people lack the courage to do things differently. Now, who on earth said that in 2017? Well, actually, it was a guy called Henning Kagermann, and he's the president of Mqtt. And Mqtt is a German Academy of Science and Engineering. So in 2017, 5 years or maybe a little bit more after Industry 4.0 was developed in Germany, the head of the Academy of Science and Engineering says that Industry 4 is failing. I think that's quite an admission, but he blames everybody else. Perhaps I'd like to say that perhaps they didn't explain it very well, and that's why it hasn't gone as well as it could have. But we'll come to that. But that's an interesting concept. Oh, and by the way, Industry 4, I'm going to refer to Industry 4 as I 4.0, I 4.0, or even I 4.0. And I don't want to get hung up on those definitions. Well, speaking of definitions, we're also going to address this one. Digitization versus digitalization. Well, let's have some analogies for those. Okay, digitization. Digitization is like taping your LPs, whereas digitalization is like selling your LPs and buying CDs. I hope that's not too old a reference. Let's have another one, maybe a bit more up to date. Digitization is like ripping your CDs onto your iPod, whereas digitalization is like selling your iPod at cash converters and using Spotify for all your music. Okay, so what does that get us? What I'm trying to say or explain is that digitization is about the media. It's about using digital media, whereas digitalization is about the process. But again, there's a big asterisk there. And I really want you to be not hung up about this at all. Don't sweat the small stuff. They get used interchangeably. And no one is really talking about taping their LPs when they refer to digital transformation of their business processes. So I'm going to use it interchangeably, and I don't think that anyone should really get hung up on that. Where we get to digital transformation, this is where it starts getting interesting. This is a slide or a table from a blog originally from a company called Jabil in the States, where they looked at different size companies. So we have SMEs, definitely smaller SMEs, less than 100 employees, then 100 to 1,000 on the top right. Then at the bottom left, we have 1,000 to 5,000, and then here 5,000 employees or more. And these are the identified challenges, the top 5 challenges to digital transformation that these companies identified. And the striking thing as you look at this is you'll see that the same headings, the orders change a little bit. It seems that the same headings appear all the time. Everyone worries about a limited budget. No one's got a strategy. The structure gets in the way possibly, and their employee pushback. So, but there is a difference. And I think this is the important one here, that with small companies, they also identify one that the others don't, and that's business partners are unable to support. That's a very interesting observation. And we saw that with some work that we've done in fact, we finished it very, very recently here in Australia. And small companies often don't have their own IT departments. They don't have their own maintenance departments. So they rely on outside companies, their business partners essentially identified here, to support them. And of course, if those business partners don't understand digitalization, they're not going to be able to help them do any digital transformation on their own systems. I'm not sure about employee pushback. That's an interesting thing. I think it's change. Everyone is concerned about change. It's interesting. I think that there is a little bit of organizational structure getting in the way, and I think that's what our mate, what's his name, Herman Henning, was concerned about. But that's it. So that's the challenges of digital transformation. So let's move on a little bit, some more sort of context. Let's talk about Industry 4 capability. And this is where we can sort of see the issues appear. This concept of a capability, especially in a small company, it's a non-core business activity about Industry 4. It's new, and perhaps no capability exists. Industry 4.0, it's a multi-stage journey, definitely. It's not something that's just a fit and forget or a single step. It's definitely multi-stage. It's actually quite poorly defined, and we'll see that sort of very shortly as well. And I think that, although I don't want to get hung up on definitions, and I don't think we should, but often companies will worry what exactly Industry 4 is. If you remind me later, I'll tell you about the game that you say, well, I like coffee, but I don't like tea. And Industry 4 is a bit like that. It's one of those games where you don't quite know the rules, and you have to pick them up as you go along. So if anyone's interested, just put it in the chat at the end. The thing is, Industry 4.0, or these stages, they require a systematic strategy. And we'll try and identify that, and in fact, we will identify that, and we'll go down this path of looking at what that actually means. So, but the question is begged, of course, then, do SMEs have a digital strategy, or do they even have a strategy at all, possibly? Especially very small companies, the vision for the company is going to be in the head of the owner and isn't necessarily written down. This is the big one. Digitalization by itself is like a table stake in a game of poker. Digitalization costs money. Digitalization doesn't provide any benefit to the business unless you do something with it. And that's the crucial part. Unless you're doing something with it, it's a sort of a sunk cost, essentially. But digitalization in itself is that step of computerizing or computerization and connecting equipment together. And that's the gateway, the enablers to Industry 4.0. But if you don't do it, and then you're not going to become an Industry 4 company, and you're not going to get the benefits out of Industry 4.0. And there are absolute benefits to be gained, but it's almost like you need to have those in mind in that first step. But if we remember that the talk is actually about low risk and low cost, and one of the areas that we've done is trying to take that high cost out of implementation, so that small pilots can be done with very little risk to the business. And that's the aim, essentially. So in some respects, Industry 4 is a bit like lean, or a bit like lean manufacturing. It's a shift in the way a company organizes itself, and I think that's quite important to bear in mind. And that also begs the question, perhaps, should lean manufacturing be a prerequisite of success for Industry 4.0 in SMEs? I'm not sure about the UK, but lean manufacturing has definitely hung around and been something that's well regarded and has outlasted a lot of the other sort of TQM, other sort of Six Sigma type things that have been around. Even though it rolls the same tools into this and uses the same toolkit, it's actually got, I think, a lot of support from industry. So finally, in terms of sort of setting the scene and context, what does smart enough mean? Okay, smart enough really comes from the phrase, good enough is good enough. And I think that's an excellent way to view systems and things, essentially. So smart enough is where we're going to actually focus on digitalization for a purpose. As I said, it's a sunk cost, but so we're going to focus using digitalization on we're going to do it to improve our productivity and our compliance to standards. And now those standards might be internal or they could be external. It's going to be management data driven. We're going to sort of ensure that this management data is to expose our processes. We're going to make sure that our processes become transparent and that exposure is immediate. So this concept of transparency and immediacy of process is what we really want to do. Smart enough is lean, definitely. But this is the point. This is one of those areas where we have to change our jelly. We're actually going to leave control and actions to the experts and their systems. We're not actually closing the loop here. We're not doing any control. We're going to leave there is feedback, of course, but that loop is closed by the operator and manager. So we're providing those people or the stakeholders in the process with information for them to make rapid, reliable decisions based on what they're presented with. And it's based around the joiner triangle. Now, I will talk about the joiner triangle later, but essentially on the right is a shot of this digital triangle. Okay, my first question to everyone. What can you do with 1 bit? Which is 1/8 of a byte, by the way. And bit stands for binary digit. And I've left that slide intentionally blank, just like the great manuals that you can buy or used to get, the paper manuals, and you have a blank page. Someone's deliberately left it blank, so I'm leaving that open. So that's a thing to think about during the chat. And by the way, if anyone's concerned about they're not quite sure what a bit is, I have a model of one here. Hopefully you can see that and hopefully recognize it, what it is. It's not too reflective. So a bit has 2 levels, 0 and 1, off and on. So just imagine what you can do with that. And that's, I guess, where we're going with this low cost system. What can we get out of the minimum amount of data? You hear about big data. This is a talk about small data, about maximizing the value of data. So we'll come back to that. And so we've got quite a few people in here, 25 participants. So we'll revisit that later on. So now we get to what I'm going to talk about. So we'll look at the challenges of introducing Industry 4.0 into manufacturing, in particular SMEs. I'm focusing on small companies here. And in this introductory presentation, I'm used to using my keys to go through this. I think I have to use, once I'm clicking the window here, I'm going to say why we need a new approach. I really want to set the scene for this vision of Industry 4. And the reason for that is that we all hear this Industry 4 story and we all hear how complex it is. We all hear how costly it is. And that's costly in terms of cash, in terms of skill, and in terms of security. And as I've hinted at before, it's possible that Industry 4.0 is too complex and costly even for German companies. We'll come to that. There's a distinction between companies that work in providing Industry 4 solutions and companies that actually want to use Industry 4 live at the coalface, essentially. And so that we're going to bring out this concept of this smart enough approach. And in the UK, there's the Digital Manufacturing on a Shoestring project. And that actually is essentially a smart enough approach. It's looking at low cost, the shoestring, and it's looking at doing these things, essentially bootstrapping it for yourself, essentially, but ensuring that it fits in with a larger IT infrastructure and that it's scalable, which is very important. And again, this idea that digitalization is the foundation for Industry 4.0. We're going to lay those foundations and what you can get out of it. And so I'm going to use as a case study Sutton Tools Industry 4.0 journey, and then introduce to you this toolkit called the Factory in a Box, which we've used successfully to teach or to demonstrate, well, both, to be honest, Industry 4.0 with SMEs in Australia. And now I want to show you this. We're going to finish off by looking at getting value from Industry 4.0. And that's what we're going to do today. And that's Industry 4.0 adoption. And I'm going to cover a little bit of security in it. And if you notice, the color's changed. And now we're going to talk about, and finally, and the reason for the color, of course, is that I want this to be emerging. I want you to realize that these things, this digitalization of you've seen is a table stake, but getting value out of Industry 4.0 adoption and understanding it as a journey even further. It's a realization that we're talking about a transition to Industry 4.0, and that the value that you get from Industry 4.0 is what you get out of it by putting in. So it's like lean manufacturing. You don't buy a tin of lean and paint it on the outside of your factory and suddenly you're a lean manufacturer, just the way that Industry 4.0 is. And that's one of the issues about Industry 4.0, that it's a lean forward technology. It's not a lean back one. So what are the challenges? Well, as I said, it's not very well defined, but there is actually an interesting definition of Industry 4.0. And I think hopefully we'll get that out of this, and that we'll see how that compares to what works on the ground and what works, in the world. So the challenges that we see for Industry 4.0, these challenges are quite large. They're global challenges. But are they always global? What about the local challenges? What about the challenges at the individual company level? Are they long-term, or are they even systemic sort of challenges? And let's see how we can meet them. So we're going to just cover this simplified Industry 4 enterprise model. So we see the different colored triangles there, and there's a reason why they're triangles soon. It looks quite Christmassy, to be quite honest. I should have stuck some balls on those. But these triangles represent enterprises. And so we're going to call these enterprises something. We're going to use maybe an unusual description of them. We're going to call them multi-level production systems. So we're going to describe our enterprise or our company as a multi-level production system. And that multi-level production system makes things. There's a one-arm bandit, a pokey machine, washing machine, and a tractor. And these we're going to consider as devices and products in the field. Well, within our enterprise, data moves. It moves from the pointy end of the top, the high end of the business, all the way down to the bottom, to the sensors on the machines. But that data does flow within that enterprise. What happens next is that when we introduce Industry 4.0, we have this concept, and this is the concept of Industry 4.0. This 2030 vision of Industry 4.0 is that these enterprises become part of value chains, of a value chain, I should say. And what happens is that we integrate them both horizontally and vertically. And when that occurs, we end up with these concepts of the Internet of Everything. And what does that look like? Well, they're joined horizontally through the cloud, for example. And then vertically, the data also goes out to the products. So now we have products as well as the production system. We have products that are actually still connected via some technology to the production system and to other systems. So I don't know if your tractor wants to know about your washing machine, but that's sort of what it implies. And that's where you see these diagrams, all these diagrams where you see everything connected together. That's where it comes from. But the reality is that it's actually the people that are important. And it's the people that interact with the devices and products in the field and interact with the production systems. And it's that interaction, it's possibly what they're thinking, especially when you look at the poker machines. That's what you're sort of seeing the importance and value in this data. Now, is it value for the individual, or is it value for the enterprise? But look, there's one other quote here, and that sort of sums up really what Industry 4.0 is about. The whole thing is a complex framework based on the full integration of cyber physical production systems. That's our multi-level production system that we've got here, where we've got intelligent products, machines, networks, and systems that are securely interconnected. That's an interesting one, securely interconnected, based on common standards independently communicating and cooperating with each other over the entire manufacturing process, with minimal or no human intervention. That's definitely a vision. That's 2030. So that is what Industry 4 is as defined. So when you see all these keywords about interconnected systems, which we'll do shortly, that's what Industry 4 is all about. Now, we maybe only need a part of that in order to get maybe 80% of the benefit. And that's what we're going to try and demonstrate so shortly. But bear in mind, it's a complex framework. We start to get told how complex it is. Now, I've been using complex and complicated. Sometimes I think that's maybe correct. Sometimes I think that's incorrect. I'll let you decide at what point I should use complicated, and or you should use complicated, and at what point you should use complex. But out of all this comes very early on in the piece, global challenges. Everyone, German companies, American companies, they all identify a lack of qualified employees, and it's one with the STEM skills that they want. They worry about data security, and they worry about excessive costs. So out of that list of 5, now we've boiled it down to 3. And the interesting thing is that it doesn't matter whether you're a leader or a follower. And I think in this particular report, which is quite a few years old again now, it's about strivers. But the point is that the leaders, they worry about data security, but everyone else actually worry about legacy systems. And that's and that's quite a few large percentage, and they worry about skills and shortage of IT staff. And there's some diagrams there. The interesting thing as well, the reason why I've picked and kept this one in is that this is about strategy. The leaders have a digital strategy, and the leaders are big companies. And then over half of them have a clear, and this is the industrial Internet of Things, so an American sort of Industry 4 version. There's 56% of them have a strategy. The interesting thing is that only a third of the respondents out of that, a third of that 56% say that their execution is actually excellent. The rest of them don't. And the similar in the strivers, there's even less of them have a strategy, and even fewer of that percentage reckon that their strategy is excellent. So that's a portent. And I don't think things have changed much. That other list, those top 5, that was I think 2018. And I think that definitely in Australia right now, everyone still worries about those same issues, and they still come up. It's not a worry. It's actually demonstrable that people worry, that people do lack STEM skills, and that's because this is, again, like I say, it's outside of the company's competence. This is just to show that there are national differences, that although the issues are global, one size solutions don't fit all. And all I'll say is that, for example, in Australia, 90% of manufacturing companies employ less than 20 people. In fact, a large percentage of them employ 0 people. There's a really brilliant term called a self-employing, a non-employing employer. So that's basically a one-man band. But look, that's going to be different. It's just saying that Australia, America, and USA are different. So I'm sure that UK is different too, to each of those two. So the challenges are definitely local. They might be national. But I think the challenges go further than that. They're actually challenges that affect individual companies. Okay, now Henning is going to reprieve himself. Actually, if you get past the very snarky comment that he made, you'll find that he does identify a really important point. And that is that Industry 4 adoption is not held back through a lack of technology. And it's not held back through a lack of standards. And that's quite an interesting concept. So what Mqtt did was they developed this concept of a maturity index. Now, if you've ever been involved in this, and I would want to hope that the people can say in the chat whether they have or not, if you've ever read this document, it's almost impenetrable. But what they do lay out is a series of steps that essentially are what the smart enough factory and then the implementation of that smart enough concept through the factory in a box actually do. And and it's computerization and connectivity, it's digitalization, but the aim is to immediately get visibility of process. So it's seeing what's happening in that. And then actually, interestingly, even though we can see what's happening, we'll take a jump, so that's level 3 up to level 5. And if we have a simple model, if we look at a simple set of data that we collect from our systems, we will find that we can actually predict what's going to happen. So we can get visibility and a predictive capacity almost immediately. The more difficult one is transparency, I think, and that's why it's happening. In order to understand why something is happening, you need a much more in-depth knowledge of the actual process. So I think that order's wrong, and I actually think the value bar on the left-hand side is also incorrect. And I'll come to that later because you see this great figure and you go and you nod your head sagely and you accept it. But I think that's a mistake, especially in this area. But we'll come back to that too. But that's where we are, and that's what the focus is on digitalization. So this narrative that we have, I'm starting to develop the narrative, and we hear that Industry 4 is complex, it's costly. It's even costly and too complicated for German companies. So where does that come from? Well, this is the definition of Industry 4.0, and I'm sure you've seen this slide or something very similar. I hope you've seen this slide already on many, many occasions. What it's showing us is along the horizontal axis here, it's showing us time. We have today, this mythical today here. This, of course, was drawn in 2014 from a graph that was, or a figure that was drawn originally in 2011. By the way, we see these industrial revolutions. The first one, the mechanical weaving loom, the assembly line, the PLC, and then here we are now with this fourth industrial revolution, where we see cyber physical systems merging our real and our virtual worlds. That actually was published in 2011, I think, or 2012, talking about production 2020. So I'm not quite sure they managed to predict 2020 very well, but that's on the way to the fourth. In fact, do you know what? That's really telling. It's on the way to the fourth industrial revolution. If you notice that 2020 point has moved to 2030, I'm sure it will move again. And that's because of that complexity side of it. The idea of self-optimizing systems, which incidentally was in my PhD, by the way, a quick plug for my PhD. But there we go. So someone's talking here. Okay, we'll just highlight that. But the point is that it's, again, which talks about intelligent products. Those intelligent products are complex. They're software control. They're going to be full of sensors and actuators. And even more complex are the processes in which they arise. Now, like I say, I often use the word complicated in the same sentence there, but maybe I shouldn't after having looked at the dictionary. But I think that's an interesting idea. There is an issue with that. So it's complex. We get told it. Okay, after you do that, you might get a little bored and you might sort of noodle off and do some Google research. So I just want to I just have this slide here, and this is actually interesting. If you looked at your kids doing any Google searches, they don't look at the text anymore. They look at the pictures. So let's have a look at what pictures there are. And this is last year. So if you do an Industry 4.0 search, this is what you get from Australia, just by looking at Industry 4.0. And you will actually see there are figures, this one here, this one here, this here, this here, this one, and this one, that are the same as what we've talked about. In fact, the same ones come up. But there is another one, and this is where we talked about this concept of the Internet of Everything, or everything interconnected. And these are the figures that represent that approach to Industry 4.0. Let's move on to this year. It's a bit of a change. In fact, what's dropped off is that step one, although the children of it are still here. But I do want to just point out one thing, and I'm rushing around a little bit, but this figure is quite important. This is toolboxes of the VDMA Industry 4.0, and that's this report, Guideline Industry 4. Okay, I would encourage you to have a look at that, and that's guiding principles for the implementation of Industry 4.0 in small and medium-sized businesses. And one thing I want to highlight on that is there's a sentence, again, it's in the management summary, I just want to quote this: the diversity of the business landscape of the German mechanical engineering industry, however, means that every company has to create its own view of Industry 4.0 and develop its own ideas for using the new potentials. That's an interesting comment, I think. But perhaps that's difficult to do. So that's essentially why I'm talking about opinionated systems, where I can provide, or the idea or the intention of the Smart Enough Factory is that we provide an opinionated system that provides a pattern that potentially means that you can, not have to reinvent everything. But it's actually very worthwhile, that document. Interestingly, that was written before Acatech in 2017 said that, threw their hands in the air and said no one's adopting Industry 4.0. So I don't know how successful it was. So let's move on. Let's look at the UK. Slight differences. We've got the state of industry in the UK, Industry 4. A fair amount of Salesforce blogs coming up. Everyone's doing Google searches, or at least Salesforce are reporting on those searches, which is a very good thing you can do, by the way, if you're interested. We see the same hands here. Industry 4.0, if you notice the sleeve and the hand, it's exactly the same sleeve and hand here, but cropped a little bit differently. Which gets me to the crux of this. There's Siemens down the bottom here, this beautiful car manufacturing plant, nice curved roof, LCD, televisions. It's photoshopped to death almost. And that's the last little bit. I do want to just, before I move on, I'm just going to move on to this. And that's doing a search for e-manufacturing. In fact, there's even, if you look on the bottom down here, I think there's some sans, what's it called? Comic Sans. If anyone's a bit of a snob in terms of fonts. But here, look, e-manufacturing. We've got lean manufacturing, just in time, agile manufacturing up here. E-manufacturing has essentially evolved into Industry 4.0. All I want to do is give it some context. So back to this definition. This is how it's been defined and how it's been sold to us. The problem is that it's imposing that view, and it's a stepwise progression. So we think that 1 is followed by 2, followed by 3, followed by 4, and 3, of course, is an automated system. So that's effectively, if today is that transition, then clearly that's just yesterday, then, isn't it? The point is that this implies it's correct, and that's a big worry. We see that and we believe it. The point being, are those divisions between these industries so clear cut? And is complexity really increasing? And did the Industrial Revolution only affect manufacturing? Now, they're questions that are deeper and potentially deeper than this presentation. But I do also want to say that QRNS is a very important. I left QRNS in there because we talk about smart systems. That's how smart PowerPoint was in terms of working out what I wanted to do here. So instead of being QQQ, we've ended up with QRS, and it still thinks it's okay. Anyway, let's move on from that. So that's as defined. I just want to bring it back now. Let's try and think smart enough. So what we've been told is this path to Industry 4 is this staged route. We start off with 1, mechanization, 2, assembly lines, 3, automation, and then 4, finally, digitization. This is the 4th Industry Revolution. The thing is, every single one of those steps was all about labor saving, and they were all about productivity improvement. The thing was that engineers, stakeholders, everyone applied the technical tools of the day to do something. And what were those things that they were doing? Well, they were trying to use these technical tools to make things, control things, and manage things. I don't think anything has changed on those 3 things from the end of the 18th century. In fact, even before then, people were trying to make, control, and manage things. So what were these things? Of course, they're the products, they're people, they're the processes, they're the factories, the offices, and the businesses. All of those activities of making, controlling, and managing, they all need insight and knowledge of the thing. And I want to point out, if it's not that obvious, of course, people here who are listening, who are business stakeholders, you have that knowledge and insight. And so I think that's where Industry 4 becomes more like lean manufacturing. You need to take that step as the business stakeholder. You understand your business, so it's important for you, or imperative to you, to bring that digitization into the business and that transformation. And providing you with the tools to do that, I think, is very important. And some of those tools seem too alien, I think, at the moment, and that's where this smart enough concept comes in. And let's redefine Industry 4. So let's actually do those things. Let's put on our loom, or it could be even on a potter's wheel. Let's put a sensor on there. Let's stick a sensor on the pigs hanging on the carcasses hanging on the line. Let's put a sensor on the line. And of course, let's put a sensor on every single person in the world. I've got one in my pocket. I'm sure you have too. We're all censored to the eyeballs, even if we don't realize it. And of course, the things, processes, equipment, assets in the company. And of course, oh, there we have the devices that were controlling the robot. And of course, you want it to be your laptop, your smartphone controlling your robot, and not some person in the car park doing the same thing, or some person in another country doing the same thing. So that's just that security aspect, is to sort of bring that into play. And this last one, digitalization is not automation. That's something to be very much aware of. So why did it become so complicated? So what's happened? What was it? Now, this is why is Industry 4 described as complex? And I want to say as well, I just want to put that out there. It's complicated the same as complex, and of course they aren't quite. So I think it's worth looking in the dictionary. But it's complex because it's been developed. The Industry 4 model has been developed from an automation model. It's called ISA 95. Now, ISA 95, ISA stands for the Instrument Society of America originally, but it's actually now the International Society of Automation. And it was a standard developed to describe the interfaces between the enterprise and its control systems. So it was a way of describing automation within a manufacturing or within an enterprise, and we'll see that just in the next slide. And so this is the ISA 95 model on the left, and we start to, if you use our imagination, we can sort of almost see that triangle forming here. So at this high level, the enterprise uses software that's stuff like the planning systems, like the enterprise resource planning systems. The next layer down, this area here, when we break it down into production areas, it's the it's the manufacturing execution systems that may or may not exist, material flow, things like that. Then down at the unit level in the cells, we're going to see potentially sort of HMIs and sort of PLCs, and then finally down at the lower level, we're going to see sensors. So that's this concept, this hierarchy of automation. Now that has been taken, and if you look at this figure in the middle, it's exactly the same as the ISA 95 on the left. But then above it, we see enhancement Industry 4.0, and below it we see enhancement Industry 4.0. So what happens outside of the top of this enterprise, this vertical system, we see popping out to the connected world. And so therefore, the connected world here gets us our horizontal integration with this value chain, this individual value chain. So we create a more complex value chain. And then down below, we see the point of that devices here in the field and the products are actually connected into this. Now, whether or not a product here will want to talk with a lathe in here, I don't know. But that's often shown, that connection is shown in its entirety, and that's a little bit why I think that we get this confusion with what's possible as to what you'd want to really do. So that's still, I think that's fairly understandable. Now the next one. Okay, just to highlight that, which we've talked about here, this is the big player's perspective of Industry 4.0. It's this horizontal and vertical integration of these value chains. Even if we might just be working in here and looking at this internal area and looking at exposing that and looking at that technology, we're not necessarily looking at, or we even have products that do operate in the field that are themselves Industry 4.0 products. We can have an Industry 4.0 production system and produce cups, produce wigs, anything at all, drill bits, for example, anything at all. But this process in the middle can be as complex or as instrumented or as Industry 4 as we can possibly make it. And because that's our process. The products themselves don't necessarily have to be Industry 4.0 products. So far, all reasonably understandable. So I did look in the dictionary. Originally, I had this as complex, but actually it's complicated. This is the reference architecture model for Industry 4.0. And you saw that popping up, if you remember, maybe if you saw that Google search and you maybe did it yourself, you'll see this figure. Now, I think this figure is completely impenetrable. It has on the side here, the hierarchy. It might be me, by the way. If it's just me, please let me know. Down here, we have this concept of a value stream, but it doesn't just go for value stream. It actually has this type and instance. And the problem is that, you know, if you're an object-oriented programmer, that might make sense to you. You know, we instantiate a type of X and we create a particular instance of that type. Well, it's a product, but okay, that's a bit complicated. So how on earth did this model end up here? And this is a little bit of a history lesson. It's actually ended up because it was pinched from this, which is a framework about a smart grid architecture for electricity generation, where each of those squares are discrete regions. They're not completely fillable, but it's about the layers of power generation, and then communication with the protocols on top of that, some information layer, and then the functions, and then potentially even the business layer, which becomes the regulatory framework. So it's it's an interesting thing, but I think this actually goes beyond complex. It starts to become quite complicated. So that's actually a good place to have a short break. But I'll actually, before we do, I'd like to ask, because we've got some participants and I don't know many people here, if anyone's got any questions, so we can spend about maybe 5 minutes. If I raised any points you'd like to talk about in this, just before we have a quick break, I'd like to offer that opportunity. I can look at people on the right. I can see the chat. If that was completely overwhelming or I'm going too quick, let me know. Otherwise, it might be a good opportunity to have a little short break. What's your thoughts, Alan?
Or was it a bit? Quite a lot to take in. I think you've taken it through nicely at a nice pace, but there is an awful lot to take in.
There is.
Maybe that's maybe people need a cup of coffee. Normally, I'd prompt Brian to interject, but he might be. I know he's very busy, so I might be putting him on the spot there. But
well, maybe what I just maybe want to ask people is that in Industry 4.0 in the UK, what's been the thoughts of where people are struggling with either adopting it, or is it are people taking a okay, you first attitude? Because that's the one thing about Industry 4 is that there is a potential for large cost if you're not careful, and it's possible that you want to see other people have a go first before you can adopt or decide to adopt it. Is that anything that people want to make an observation of? Or do we have any SMEs and manufacturers and coating companies on the call that might be able to comment? I'm trying to do like a sharp end sort of a discussion. and not necessarily an academic one, but I do want to set the scene properly.
Hi, Steve. It's Brian Alcock here. Hi, Alan. I am here and watching intently.
Thanks, Brian.
Not at all. It's absolutely fascinating, and I think this is the best way I've ever seen this presented. I think the pace is absolutely spot on. But as I've just put in the comments box, for me, this is a learning experience more than an interaction. And I mean, I know you want this to be interactive, but there's a lot. Yeah.
Yeah. Oh yes. If it's new, I want to be informed on that, because it's a lot of people hear about Industry 4.0, and even though it's, some of the slides I've got, they're actually 5 years old, and in fact the concept that we're piggybacking on is almost a decade old, yet it's not adopted very well even in Germany and USA. I mean, a couple of years ago I was in New Zealand and getting a presentation on Industry 4.0, and the New Zealand's a fascinating country, by the way. They're out there. I could be rude about where it's located, so I won't, because it's but yeah, they've essentially become very self-reliant, and so they've developed things themselves that are very good and world class. But they looked to find out about Industry 4.0, so their manufacturing groups toured. Well, they went to America, and they went to Germany, and they actually struggled to find companies to visit that were SMEs that could demonstrate adoption of Industry 4.0. And one of the things that's, well, and I went on a course a couple of years ago to Aachen, and they work with a lot of SMEs in Germany, and their take on this is actually they actually take their take is to look at lean manufacturing and introduce that lean concept. Yeah, look, that's a really one. Also, it's Andrew has observed. Yeah, that's it. If you've got 30,000, 40,000 pounds, dollars, whatever you want to talk about it, then what would you rather buy? What would you rather spend it on? Oh, and in fact, the observation there is that the software. This is, well, what I'm going to do, Andrew, is that's the next bit of that's the remaining part of this first workshop is to start to introduce and show that what we did at Sutton's, it's possible to not do and go down that Siemens software approach. The fascinating thing about Germany is that engineering is very well regarded, obviously, as we're all aware, and they have that middle, what's it called, that sort of that middle-sized company of around 250 people. There's a lot of those around, and a lot of skill, but their engineers are well trained, but their way into their computer is the PLC. And this is what Industry 4 was developed on, and this is maybe more background, that essentially Industry 4.0, or Industry with the IE, was a way to protect the German automation industry, because as computing costs drop, the ability to automate is available to many countries and people. So it's what's next in automation, and that's this. Well, it's not just cyber physical, but the biggie there is that the German PLCs are all essentially very high power computers. They're all Intel processors, not sort of ARM or RISC-based processors. They're all very high end, and so they're quite capable. So a well-trained engineer's route into the corporate, what would you call it, the corporate sort of network, or the corporate sort of enterprise service bus, to use the right term, is through the PLC side. And so that connecting that together through that architecture is something that is seen as a way. And that's, well, before we have a quick break, it's a bit like the Borg, isn't it? How do we all get assimilated if we're into Star Trek? The point is that how do we actually integrate everything? Well, we all use the same system, so there's no problems. We all talk to each other. So that's something that I want to try and move away from, to show that that we can do these things. So shall we take a quick break and be back? What time have we got? Let's have a 5-minute tea break or coffee break.
Steve, I'll just I'll just reiterate what you stated, is that we're going to make this three courses. So there's going to be this, and then there'll be one in probably early February, and then maybe at the end of Feb. Because originally we'd announced it as 2, and then, as you said, and as we discussed, Steve, it's really it can't really be done in 2. So people are going to get 3 free events. Okay.
Yep.
Yep.
Okay, so I know that time is valuable for everybody, and we're coming up to 9:20. It's 9:27 here in the evening. It must be whatever time with you.
Yeah.
10:30.
10:27. Yeah.
Yeah. So restart again. If I just mute my video, back at in 9 at sort of 10:35. Would that be good for everybody?
That'd be great. And just to reiterate, we're going to have an 11:30 exact stop to keep in with everybody's diary.
Okie dokie.
Yeah.
All right. And if there's no more questions, but if anyone feels the need to stay around and write things in the chat, then please do. Okay. All right. Steve. Well, I'm gonna go quiet.
Thanks, Steve.
Although the host wants me to unmute. Back in 5. I've got the wrong glasses, Alan.
You got the wrong glasses?
Yeah, I have, yes. Be back in a second. Oh. Problem is, I've let with the dog's going nuts in the house. He wants to go. Back in a tick. Right, are we 9:37? I think we've had our 5 minutes.
Yep.
So I just start.
I'll just point out that Pamela's going to send everybody a poll at the end just to ask them about some feedback on the talk. You know, what their impressions are, any comments from it. Okay. Press ahead.
Just to add, it will come in an email.
Yeah.
Thank you.
Thanks, Pamela.
Okay, welcome back, everybody. Let's move forward. Now we're going to introduce Industry 4.0 that's smart enough. So, and the concept for Industry 4.0, smart enough Industry 4.0, is that it's for all types of organizations, not just for automated manufacturers. It has a small company perspective. It's not for solution providers. And there's a third one here. Well, of course, we've highlighted this already, but we're going to be really focusing on digitalization for something, and that's productivity and compliance. And that's how we're going to get value from Industry 4.0. I showed this earlier. This is our digital triangle. This is what we're coining a smart enough digital strategy. And the reason for introducing this is in blue on this side here. The point is those reference architectures that I highlighted, they're complex, and they don't provide any guidance, anything about digital thinking, which essentially is a prerequisite for Industry 4.0 adoption. And what I've done is pick the joiner triangle. Now, I think if anyone wanted to comment, I perhaps won't talk about the joiner triangle too much, except to say that it wasn't just a concept about total quality and about sort of this organization about focus on quality. It was actually an organizational structure as well. And Ford actually took this up, but that's a slightly separate concept here. But the point is that we take the corners of the triangle and we assign them some value, and we're going to call this one source of data. The original concept was all in one team. We're going to call this triangle, or this corner of the triangle, a focus on productivity and compliance, where the original one was a focus on quality. But of course, you can start to see that productivity and compliance are essentially a subset of quality. It's effectively the same discussion. One team meant that everyone in the company could talk about quality and about the solutions and have the same language to describe things. The equivalent here is a single source of truth. Now, that doesn't mean a single monolithic computer, but it means that things aren't repeated. We don't repeat ourselves. And that's our data store. And we access that data store through web services and our ICT systems. And that's through REST services, SOAP-based services, CRUD, which is a database sort of concept. And we also access that through these technologies like Mqtt and OPC UA, which are sort of, these are protocols for Industry 4.0 or IoT in protocols that are very, very useful. And the scientific approach here is essentially the same thing. We're focusing on data-driven management. So it's evidence-based decision-making, exactly the same as this original drawing a triangle. The reason for it being a triangle as well is if we take any of these corners away, the whole thing fails. So all three things have to be present. And if we focus on that, it provides us with something simple. It provides simple guidance that distills the concepts of digitalization. The idea is we're doing it for a business purpose. It's not just a technological thing we're doing. And we're doing it to improve a business metric. It emphasizes the fact there's a data source and there's a means to access it. And we're going to use internet technologies, and that's our Industry 4 technologies. And it closes a loop on why and how the data becomes knowledge or business information here. And that's the analytics side as well. So that's why this strategy is important to define really early on in the piece. And then we maybe should say, what's management data? Well, it's a simple but important stuff. It's the really, really simple stuff. So we can ask of our system, what are my machines doing now? So that's things like machine state or system state or process state. Is it idle? Is it busy? Is it on or is it off? And that's going to help us intervene in that process. So we can look at process health, we can look at maintenance and management if we have this information of what my machines are doing. And what are they likely to do next? So this is where we saw that sort of process, revealing of the process, that transparency, but also this predictability. What are machines going to do next? Can we achieve our forecast or our target, which is forecasting? And how much have I used my machines? These might be metrics for the business that you want to know. And that's derived from the state of the machine. We also might want to track our assets. So we want to know in that transparency and immediacy, it's transparency and immediacy of location, something outside our ERP system if we have one. And so we want to see work in progress, we want to see queues, we want to see bottlenecks, and we want to see that in real time. So that's the sort of management data that we're talking about. So now possibly you can start to answer this question. What can you do with one bit? And again, it's a bit blank, but here I might actually maybe fill in those blanks for you. So if we know our state, our switch, which is the state of a machine, we might, as soon as we do that, of course, this bit doesn't just float around in space. We store it in a computer, and computers have clocks. So of course we can actually count things. We can count them, and we can count when they occur. So, and we can also work out the time difference between events occurring. So we can look at rates. We can store these, and then we can do lots of basic statistics. We can look at the averages. We can look at the we can look at this over time. We can look at the last event, or and we can possibly predict the next event. So all of those things start to become available just with a single switch and a clock, and the ability to write these things down. So all of those rate-based ones. So there's maybe about 10 or maybe, well, at least 10, I think, measures that we can do with one single bit. And that's actually very useful for a business to do. And that's literally with one digital input, and that's all. So that's the bit that I want you to think about that is possible to do with this. And we'll see that in a very few slides about how that's used. So smart and smart enough. Let's really focus on those things. Let's pick the pace up. This is obviously smart on the left-hand side. Well, that's what it thinks it is. It thinks it's smart, and this is smart enough. So that was a smart enough strategy. This is a process, the smart process on the left-hand side. That's something that you might be aware of. Augmented reality. This is an image from Festo in this beautiful white factory here. A crisp white shirted production manager potentially with his HoloLens pinching on a machine to look at what's been produced there. Of course, he could just go on the floor and ask the operator, or he could. You have to be careful, of course, not to fall off the balcony, but that's another story. And of course, this is the smart enough approach. And we could have done this the last 10 years at least. I'm not sure what year the iPhone came out, but I think that was that could scan QR codes from the get-go. You print a QR code on a label, you scan it, and then your phone can be immediately taken to a live web page. It could be a video, it could be an SOP, and that's doable right now. So that's, I think, the reality. So on the left, we've got the augmented reality, and on the right, we've got the real reality. So that's something that can be done. Yes, of course, augmented reality is fantastic, but these things so we can actually have a process that we can make smart enough, or we can use technology that we've all got in our pockets to enhance the ability to do things without having to spend a few $1,000s on our HoloLenses. So here's a machine. This is the latest Anchor CNC grinder. Those tools that are on the pallet there, they're actually aerospace cutting tools going into Europe. This on the right hand side is a Windows 10 touchscreen with a multi-touch display panel. The whole thing's got OPC UA built in. In fact, the time this was last year as a new machine. But that's a great machine. It's actually fairly well and fairly easy to integrate into Industry 4.0. Already it has, like I say, an OPC UA server. But this is the reality. This machine here represents the legacy machines that we want to connect in our factories. In fact, this one might even be older than me. But it still works. It's been maintained and serviced, and it's a grinding machine. It's a fluting machine from a company called Normac. I don't think it's even got a CNC control on it. It's all relay controls and hydraulics. But the point is, it's been retrofitted with this sensor, and the sensor's in the plastic bag on top. We'll come to that shortly. And this sensor is picking up events from this machine. In fact, it's picking up push events here, and it'll be picking up some other start and stop events as well. And in the background, if you see it, in fact, I'll just highlight it. That's the bit we're going to look at in the plastic bag. That's a low-cost sensor. And then on the wall behind is a plasma TV that was pinched from marketing, and that is the display. And that essentially is what the Smart Enough factory is. So what does it do? What do we see on that display? Now this one's been blanked off. Now that's an interesting one. This is a publicity photograph. It actually still shows some quite revealing information, and that's one thing about Industry 4 that we have to be aware of. When we actually make our processes transparent, everyone can see that 3 of those 5 machines is actually not going to produce its target with those red circles. Even though we blanked the target off, we can see that we've left the predicted total in there and the stop time. So that second machine's been stopped for 2 hours in that shift. We can see the previous shift's activity. We can see that the displays are full even though they've been deleted. We can see the average cycle time, and we can see the stop time. But the point is, this is a visual tool that's been deployed at certain tools, and it's been deployed on bottleneck machines. We've put dashboards on production lines in New Zealand and in Australia. It's web-based, and it's based around this 802.15.4 wireless sensor network. We pass real-time data through to a dashboard, and we also process data. It can be processed happens to be processed in the cloud. We're using an Amazon Web Service database, but it can be done on a site or on premise, as we like to say, on-prem. I think there's a posh way of saying it. But it's event-driven, and it's ready for data reporting. In fact, one of the things that the underlying database structure is actually it's actually a data warehouse. And this is that pattern of Industry 4.0 that I want to show you. And as I say, that the one thing that I started off with was that, this is essentially opinionated. It's showing you one way of doing it, and providing a method and providing a visualization tool. So let's, I did actually, I think, eat a thesaurus here, or a buzzword, looking at buzzwords. This is a couple of slides that's going to show you about Sutton Tools itself. And it's this Industry 4.0 journey about information-driven manufacturing. And I think I titled that one, Joining the Dots in a Disruptive Landscape to Bootstrap Innovation and Create the Smart Enough Factory. So drum roll, please, I think. Okay, a little bit about Sutton Tools. Sutton Tools was actually founded by a couple of English guys in 1917, a couple of brothers. Its headquarters in Melbourne, Australia. It manufactures round shank cutting tools out of carbide and high-speed steel. And there's some examples of some coated product that we manufacture. We make high precision quality cutting tools. We have about 20,000 SKUs, 1,500 product families. And this was a slide that was made for us by another outside group some years ago. And I thought it was quite interesting that they said that we'd done rapid expansion through acquisition in those 100 years. I'm not quite sure how rapid that is, but there we go. Sutton's is essentially did or has acquired Patience and Nicholson Frost, all the manufacturers of cutting tools in Australia, and essentially it's the largest cutting tool manufacturer, the major cutting tool manufacturing in Australia, and it exports into Europe as well as Asia. There's a lot about knowledge driven, this idea, and I think that we could really call that servitization. I think that's the input. That's a good way of looking at it. That the data that we collect at this point, and what we saw before was that it's about servitization. But one thing to just highlight, the fact it's a 100-year-old company, 103 years old, I just wonder how much we've forgotten in that time. And that's, we'll come to that concept of memory in a little while. So I would say that Suttons were great at making cutting tools. And this is an oldish slide, but I wanted to just highlight that this might be the reality for a lot of companies, especially small companies, where on the left, we can see Inform, which is an ERP system, a Salesforce, a quality management system, a website, and a production design system. And the glue holding it all together is Excel. In some respects, in some companies, Excel takes the place of some of those systems, and that's it in its entirety. And the point was that in 2015, there was no real integration at Sutton Tools. And so that simple idea of integration, this is all about web services, is that, for example, if there was a service on a customer in the ERP system, that we could, through an external component, make sure that Salesforce was updated if this changed, so that data was pushed through this flow automatically to maintain these systems, these separate systems, to maintain that data integrity. And it's a really simple goal, of course. One thing I did do when I did this slide originally was think about if we'd all learned Access instead of Excel, and object linking and embedding, that perhaps this would be a different slide, but we didn't, because Excel is such a good tool. It sucked us into sticking with this process for the last 20 years, perhaps, where we maybe should have been looking at a database. But that's another story, of course. So we talked about dots early on. What are the dots in this particular case? What were the dots that we joined to look at on our journey into e-manufacturing? Well, it's actually about business process re-engineering. And if we went back to the 90s, we'd hear that a lot about business process re-engineering and business process mapping and things like that. But I think they actually define the technologies and the skill sets actually for Industry 4.0. And so this is a little bit out. This is out of Wikipedia, and I've actually filled this up with all of the technologies that it talked about. And it talked about shared databases. It talked about expert systems, telecoms networks, decision support tools, wireless data comms. So far, so good. We can recognize those, and portable PCs. And then the last one, which I think is great, the interactive video disc. And that would be to support our customers. The interactive video, we're now on the interactive video disc, everybody. I think that's not quite as catching as Zoom, but there we go. Automatic identification and tracking. In fact, I have a lot of, they're all here because, of course, and we'll see this later, a lot of Nerf guns with RFID tags on them. And that's because of one of the student projects that I've just done a little while ago about the Smarty Nerf gun. And you can obviously like the pun there. But the point is that all these tools, all these things were highlighted as being tools that would actually, we could re-engineer our businesses with. And automatic identification tracking, RFID, of course. And then high performance computing. But what's new since this slide, or since that concept? Well, of course, the internet's new. Web services, IoT, high level languages, and that's where we come through with a factory in a box as well. That those high level languages and configuration tools that enable this citizen developer, the people like myself and the people who work in companies who are the tinkerers, the makers, who can actually create competent middleware for use in businesses. And that's what we're going to hear about. And then there's this concept of business process modeling and notation. That's a nice one. But the latest news, that complexity doesn't equal cost. The software and the technology, the hardware, sorry, the enabling technology hardware and the software is now very low cost. In fact, we can't even buy Excel anymore. We have to rent it, because that's how they've worked out that they can sell it to us. Because if they sold it to us once, you know, they need to change the models. Hardware has become cheap. Software, in some respects, has become free almost. But at Sutton Tools, let's get back to Sutton's. What does information-driven manufacturing mean? Well, we started off with collaboration tools, and that was their Web 2.0 tools, platform as a service like Confluence, for example. It allows us to collaborate and write stuff down. Web 2.0 is where we actually have the edit button. We're actually writing content. And this is an example of content. This is a very old Confluence page. And I've deliberately left this in because this is an edit by Peter Sutton, who's now the MD of Sutton Tools. And so this concept of all in one team, everyone is involved in using these tools. Integration. If we take those web tools and we put on some web service technologies, which are there free, essentially, with it, and we pick some tools like RAD tools, which are rapid application development tools like Oracle Application Express, we can very quickly create data management middleware, or we can supply data, which is what we do, to directly to external businesses. They can consume those services, which can provide data to their systems, essentially our catalogs, as a RESTful data service or as a RESTful web service. And then digitization. If you take the web tools, the web service technology, and those RAD development tools, and we then add some tech on top, which we're talking about sensor networks. In fact, we're talking about these devices that we saw on the beginning of the presentation. This is the board that's behind the behind that image at the very start of the presentation, and it's got one of these devices plugged in. In fact, I maybe should plug it in and wave it around at you. This is what we're talking about: low cost sensors for taking data from legacy machines. If we do that and we put in some microcontrollers as well, we get that smart enough factory. We get the industrial Internet of Things. And of course, nothing happens after that until, oh, I got the order slightly wrong. I want to see this. I want to see compliance and productivity. Those things emerge. Once you've got collaboration, integration, and digitization, or you're at that point, then those things are emerging things. You know, you don't build productivity in, productivity comes out of it. And the bit on the left there is this is a little bit of a, you may or may not enjoy this. I don't want to take you to school, but I do in some respects, is I either want to scare the horses or I want to just get people to understand that it's not that difficult. The point is this: on the what we've just seen there is actually some Mqtt showing up, and that's how we get data. That's our this concept of cyber physical systems. You know, we're going from the physical system, and this is the interface. These tools like this are the interface between the physical and the cyber, and then we can create these strings of data. So what's that all mean? It's a string. It says the word string here, so let's follow the string. I like following strings. Let's see where they're going to lead us. Okay, into a little bit of string theory. Okay, we've got this concept of an address. You might have seen that on the other page. It's actually quite readable. It says Thomastown, plant 1, drill line, and then a number, 1984. That 1984 is an address of these devices. This one happens to have an address that we might want to set as 774B, just like which street it's on. And then we have some payload. Now this is JSON, JSON. If you've seen XML and been a bit frightened by XML, this is a lot lighter weight, but it contains the data. In fact, the little square brace means that it's an array. The bit in the next bit is an address of the sensor. This is the data that we might want to transmit. This happens to be 2 bits. I'm sorry, I actually put 2 bits in here rather than 1. And then this is a thing called the epoch timestamp, and that's a number of milliseconds since the 1st of January 1970. Now, incidentally, there is a thing called the billennium. We've had the billennium. That's when we went past 1 billion microseconds since 1st of January 1970. And if you worried about the millennium bug at all and can remember that, there's a thing called this is going to run out, this string, in 2030. So 2030 is going to be a bit of a disruptor potentially, because this timestamp that's used everywhere is going to need to be replaced. It's going to have to turn into some sort of 64-bit version. And then let's focus back on the data though. 1, 0. There's a joke about that, isn't there? There's only sort of 10 people who understand binary. That's me and you or something like that. But anyway, there we go. That's another poor joke. But the interesting thing about this is that I've labeled them. I've labeled the left-hand side, and when I ignore them, I've labeled it the ignore machine state bit. And on the right-hand side, I've labeled it the machine state bit. Perhaps it's time for a model. Okay, this is our switch. So if we have a process and it's merrily moving away, there might be a point at which we want to ignore it and not see what's going on. So literally, we can use the other bit as a mask of the first one. So we can, with 2 bits, we can have 4 states. Often only 3 of them are valid, but that's in the story. We've got 0, 0. So we've got 0, 1, 2, and 3. So 4 things we can now measure with 2 bits. That's the power of binary. But what else can we do? What does this enable? And this is where we get to the interesting bits. It enables, of course, IoT. So let's look at some IoT things. This is our dashboard. We can see 3 machines on this dashboard. We can see a production goal. We've predicted that this production goal is unachievable. If we want to dig down into that data, we can click on it, and we can see the details of that machine. We can see that its goals per shift, its parts, it's the difference in between the 2, the cycle time, the idle time, the last 5 minutes, someone. And again, that's based around, in fact, here we can see just that 1 bit of information. And that's how rich we can make it, by having a few things to support that. We can send ourselves emails, or we can have the system send emails. We can have the status to be updated. We can look at utilization. We can see parts per hour. And all it takes is persistence. Now that's very much a dad joke, actually. If you're any computer scientists will be rolling around on the floor by now, because of course it refers to persistence of state. So there's a state happens on these machines. It's transient, it goes, but a database allows us to store that state and to come back to it later on. So that's the important bit. Okay, so that's IoT. So that's where we are. So this is the real system. This is what, if we looked at the dashboard, well, we can't do now, everyone's gone home, but that's what the live board would be. Okay. This is another screen. We can see this 10-day moving average. So as we build up and collect data, we can start to enrich it, and we can start to look, especially when we write down our goal, we can see how we're doing towards our goal. And this shot was actually taken on a day off. So this would be the parts total for the last few days, in the last 10 working days. We would see here a graph which would show the parts by the hour. We would see the dots representing the current product being made, and we'd see here bars of utilization. But right now, no machines are on, no utilization. Now, this is the interesting thing. All of that replaces this. This is a lean manufacturing board, a sort of a factory visualization board. Now I've scrubbed it out, but essentially it identifies for a machine, it identifies a target that's up here. These numbers here are the targets. And these represent the shifts. And if you see a green splodge, it's the target was met. And if you see a red one, the target wasn't met. Of course, this board has to be made daily, but it's made and updated the next day. So you know the day after that you didn't meet your target. This is actually quite an interesting thing. This is a tool that allows you to have a toolbox meeting and to stand around the board and to discuss why you didn't meet the target yesterday, perhaps. With this system, we can say, why are we possibly not going to meet our target today? In fact, in the future. So that's the point of modeling, and that's where we have a very simple predictive model for the volume that's going through there. So if you can have if you can model your system, potentially you can predict what's going to happen in the future. And if the simpler the model, the easier it is to predict the future with it. And that's the power when we talk about immediacy of process. And now you can see what's behind the dashboard. So that's where we get to the factory in a box. Now the factory in a box, well, let's look at the schematic first. So we've sort of seen some hints of that. But this really, on the right hand side, we see the machines. And in fact, you can actually see a prototype. So this is a prototype board on a breadboard with a off-the-shelf power supply, and one of the XBs that feature on a lot of the pictures here, and some very simple signal conditioning. So the smarts are all in here. And then we have a broker. It's an Mqtt broker. So all this thing does, every time an event happens on the machine, it transmits a message to this thing here. They all transmit messages to this when something happens on a machine. And then this Raspberry Pi here, which it is in the box here, that actually publishes that message. So there's a publisher and a broker in here. And then on other systems, we can have an Mqtt listener, which might have Node-RED running on it. And on that Node-RED, this is the editor, and it's a graphical editor where we drag and drop graphical objects onto here and we configure them. This is what has happened with software tools. We configure things. We do as little programming as possible. We just configure these nodes. Now there are some programs, and of course you can tell if you look at this carefully that perhaps data does travel down these wires and gets distributed. So the logic in the program is quite visual. And then we can display it on a phone, for example. So that's what the schematic of the system is. But let's look at the factory in a box. Now the factory in a box is something that we developed as a capability enhancement, and an Industry 4 capability enhancement learning tool. And it uses the same hardware and software as the visual factory you saw at Sutton's. In fact, the board here represents the factory. These are the machines with their light towers down the side here. And these are the sensors that are on the machines. So these devices, which are Arduino based, actually act like machines. And this is the difference between what you might have seen being developed with Siemens and the larger companies where they have these reference systems. The point of this system is it generates data, and data is a new thing that we need to learn how to deal with. So all this is to do with is to generate data for us to process using open source tools that it's made up of, and it's completely open for modification and configuration. That's the idea. We use Node-RED, a database, and these Arduino based devices here. There's a Raspberry Pi, and underneath the top layer there's a Chromebook or a Surface Pro, depending on what you choose. But what it does, it allows multiple levels of engagement with users. So if you're learning about Industry 4.0, you can see it in operation and understand that. But if you're a technician or if you're a student, you can take it to pieces and you can build your own applications, and you can thoroughly work on it. But essentially, with the way it's been deployed, and we worked with the Queensland government just recently, where companies had this kit and they also had these extra nodes, And so they could use the kit to sort of inform themselves about the system here. And also at the same time look at deploying some of these nodes on their own machines to look at collecting information about utilization, for example. The point is it assists in converting data to knowledge, and that's what we need to be able to do. And it fits the shoestring approach to Industry 4.0. These devices, when we're looking at connecting it or to create these from machines, were about 100 Australian dollars. They can be miniaturized. In fact, there's some smaller versions here. We'll sort of see that. So you can get them quite tiny. You can make them quite tiny, or you can make them a little bit bigger. Really up to you. But the point is that's just very low cost data collection using existing sort of standards. Just a quickie, just the machines themselves, they're pretend machines. You know, we use them to create data, so they break down, they take time to fix, and they respond to the alarms and the warnings. They run out of work. You know, their input buffers run out, their output buffers run out. In fact, this one's actually feeding itself, if you notice where the wires go. That's one way of doing it. And so they are physical discrete event simulators that generate data for an Industry 4 system to digest. Why would we do that? Why would we create this hardware? Well, of course, it's going to be done in the software, but we're aiming these sort of systems at mechanical engineers. And so as a mechanical engineer, it's something physical. It also actually is quite useful because we can actually put this out on the floor and just see if we've got any reception. But if it's affected by noise, for example, and we have to do some filtering, but that's another story. But the point is that it's a real physical thing that actually emulates very closely what's happening in the plant. And it allows a safe and low risk way of using potentially even will students in this area, and we'll get to that shortly. So what I want to just highlight is that, of course, this is something that we do in Australia, and that we've run these workshops with these kits. And of course, when we do these workshops, we don't just provide the kit and leave people to it, because that's just the same as the Architect issue. We use a conference wiki as a digital twin for the factory in a box, which contains how-tos and background support. We also provide individual technical support to companies as well, and have plenty of group meetings. So that's how we would do that. But one thing I want to highlight for you is that there are YouTube tutorials you can find and walkthroughs that are available for anyone in the world to view under the Smart Enough Factory. So you can find some of the resources that have been provided, and you can see for yourself and view those for free on YouTube. But of course, this course is not looking at providing the factory in the box, but these things are, like I said, the YouTube videos are completely available. And it looks like there's a link to YouTube. I'm not quite sure if it's oh, in fact it is. Look, look, I won't click it because we'll end up going to YouTube, but the link is there. But finally, let's just pull things together. We talked about that ISA 95. Now this is the ISA 95 model in a different, shown as a different way, as a triangle. These are the layers in it, the business layers, and it might be that down this side we have our ERP system, our manufacturing execution system, our SCADA systems. Here, our PLCs and our sensors. And the factory in a box connects at this sensor level, and it's sensing only, it's not controlling, and it provides this dashboard. Now we potentially could connect to an ERP system or an MES system and feed data into there. But then here, the loop is closed by the person, by the stakeholder. The other interesting thing, of course, is that not everyone's systems are the same. And it's possible that you won't have a manufacturing execution system in your company. It's also quite possible you don't have any SCADA systems. Now, SCADA is that supervisory control and data acquisition systems. You might not have that if you're a batch manufacturer. You might not have an ERP system. You might be relying on Excel. And in fact, you don't need any of the systems, any of those layers to exist in order to have sensors and signals. And that the Smart Enough Factory will still work. And that's the idea, that it provides In fact, itself is actually partially satisfies that ISA model. It becomes part of a manufacturing execution system. It's part of, if we understand overall equipment effectiveness, it's actually provides us with that visualization of availability, for example, even with a very limited number of sensors. And that's what we can do with the smart enough factory, which gets us to this point, getting value from Industry 4.0. And I want to go through this slide quite slowly. We're pretty much at the end of the presentation, but I think it's quite an important thing. And this is actually from Mqtt. And the reason for doing that is that in Australia, this is Australian business data, ABS, 60% of businesses say there's no value in IoT. That's a relatively recent statistic. People worry about cybersecurity threats. And the thing is, with Industry 4.0, it's new stuff to think about. You know, you're busy trying to make a living. You're busy trying to ensure that, you know, your company can survive COVID-19. What we're going to do. And that's the point. For a lot of people, they don't believe there's a clear value for digitalization. And of course, one of the reasons for that, it's not the core business. So let's see how that can be addressed and how Mqtt did it and how I think it's a very valid point. So what we've got on the right hand side here are two graphs, figure 1 at the bottom, figure 2 at the top. So figure 1 down here and figure 2 above. Now, this is a very crucial sentence. Now, of course, it's German. It's actually quite difficult to say, but let's try it. The chief economic potential of Industry 4.0 lies in its ability to accelerate corporate decision-making and adaptation processes. So adaptation processes. So corporate decision-making and adaptation processes. Okay, what's that mean? Okay, if we can remember anything about Taguchi, we can see that everything about quality, there's a cost of quality in doing things, or cost to quality in doing things. Everything has a cost. So, for example, what this graph shows, it has time along the bottom here, and this vertical axis here is called benefits value of adaptation. So what it's showing is if an event occurs, where my mouse is here, if an event occurs on a system, then there will be some loss of value or loss of quality until at some point after this latency period that people are aware about this event occurring. So insights about the event become available. So there's a latency there. And there is already a significant loss of value occurring. Then potentially it takes time again to analyze why that event occurred. And that's the analysis latency. And again, more value is lost. And then longer still, there's a time it takes to make a decision. And so until the countermeasure is approved. And then finally, the action latency, how long it takes before that countermeasure takes effect. And what's happened is that if we look at that, if we project it across this vertical axis here, we can see there's a very large amount of value being lost from the event occurring to the countermeasure being applied. Now, what Industry 4 does, and this is what the concept is, that it's accelerating the corporate decision-making process and the corporate decision-making and adaptation process. So that's adapting to those changes and problems. So what it's done is push all those events much closer together up this loss of value curve. And so what's happened here is that from the event occurring, that very quickly we see insights about the event. And what this represents is A, B, C, and D. These represent technologies of Industry 4 that can be used to reduce this latency period as much as possible. And it's quite interesting what's defined as these ones here. So the very, very first one, the insight latency from the event occurring to actually seeing it occur, is having real-time capability and systems integration. So that's our digitalization, it's our computerization and connectivity, and having a real-time capability. But that's only if something's visible. Okay, so that's the visualization. So that's exactly what we're talking about in the factory in a box. Then the B here, analysis latency. Now, of course, I can be quite flippant here, or quite, I don't know what the right word would be, but I can say that we've got big data analytics. I actually think that small data analytics are much more important, but that's another story. But the point is that we can apply, or that you could apply machine learning or analytics to work out why that event occurred, about providing sort of some analysis. And then the C, the next stage, this decision latency. We might have a decision support system, we might help us visualize the process. But there might also be some automated decision making in there, some business logic that makes these things occur almost immediately. And then finally, D, this last one, this action latency, where we've got this integration. I'm not sure how they managed to squeeze this one in, but vertical and horizontal process and systems integration and cyber physical systems. Well, of course, I think the fact is we've got a cyber physical system, we've got visualization, and we've got some integration of systems and real-time capability. And I think that, as you can see from this diagram, that potentially this is what they identify as the largest loss here of value is about insight. If we can do that, then we can actually save a significant amount of value, which can be measured in monetary terms. And I like to just reflect then on this data-driven manufacturing, this concept of our digital triangle, and some of these things here that come out of this, you know, not just sort of these technological elements. So I can also mention some obvious ones like business information reporting, connection of sensors to our I want to say component measuring systems, but it's not. It's, of course, it's our sort of maintenance systems, our computerized maintenance systems. That's a useful thing to do for sensors too. Data input devices everywhere. We can put apps everywhere, and we can look at automating our data collection. But the bit that I wanted to stress as well is that when we look at this, it's not about full automation, and that's that phrase I used earlier, I like coffee, but I don't like tea. I saw a Siemens presentation when someone talked from the mining industry and said, look, we've got all these systems, you know, we've got our automated lines and all this sort of lot. Is that Industry 4.0? And the Siemens guy said, no, that's not Industry 4.0, that's Industry 3. But he didn't say any further than that. So he didn't let them in on the rules of the game there, which I thought was quite interesting. Quite an eye opener. But that's the value creation. I will talk a tiny bit about security. Of course, we can find lots of information about security. And we did a work with RMIT, the cybersecurity master's course. Down there on the list is a list of things which you'll see later on about how you can be easily hacked, and it's weak and guessable passwords. So of course, they used our factory in a box kit to test their cyber attacks. Did they succeed? Well, it was quite interesting. We Hacked a Factory was the title of their presentation. Ask me about that. It was quite an eye-opener, but a very interesting one as well. And it's very easy to actually deflect those attacks, and what they were able and not able to do was quite interesting. So in summary, what have we tried to cover in this very, very quick 2-hour session? I just want to emphasize that you don't buy Industry 4.0. And of course, it covers a wide range of ICT sort of activities. The implementation isn't necessarily easy, especially if you haven't got a strategy. Well, why? It's because it's nitpickingly detailed. We've got to understand our machines and our process in great detail. But we've also got to have an overview of the business. In fact, if you look online, you ought to search out this podcast from a guy called Charlie Peters, this GigaOM podcast about the last digital mile or the last digital rule. But the point is, we can actually, these problems of cost, risk, and STEM skills, we can actually engineer those out to a certain extent. But it's about projects. Focus on the business need, I would say. And it's not a technological approach, first of all, but be guided with this simple strategy. And the point is about STEM skills is that it's nice to know, and this is what the factory in a box comes in at doing, and this concept is you need to know what you don't know. And that in that way, you can actually scope activities to integrators and developers in this space quite effectively. But the point is that the cost of entry is extraordinarily low. And the STEM skill set as conversion, it shrunk significantly since that 1990s business process re-engineering activity. And once we do those things, a collaboration, integration, a digitalization, we can enable and enhance productivity and compliance. well, it's Lean Industry 4.0. Just do it. That's the last thing to take away. Let's move on quickly to the digitalization workshop, the next bit. And this is the foundation phase of Industry 4.0. We're going to look at how to do smart enough digitalization, how to create that Industry 4 pattern. So what I'd like you to do potentially is to think about the processes you'd like to have digital information from. And I'd recommend as well the guideline Industry 4.0 document that I mentioned. And I waved at the screen. I'll wave it at the screen again. I'll try not to do that. Guideline Industry 4.0. That's, I think we'll use that as a foundation. And if you could look at that before the workshop, the following workshop, that'd be really good. So that's
we send that out to everybody, Steve.
Yeah, look, it's online. I can send a link possibly in the chat if I'm quick.
Okay, so Pamela will send all attendees a copy of that.
Well, I don't think I can actually send you a copy of it. I think you need to download it yourselves, because if you look at trade.
Sorry, yeah, that's what I mean. Yeah.
Okay, I'll do that shortly. I was trying to find it. It's the tab's not open. Look, just on a well, it starts on a light note. Let's look at automation fails, for example. Actually, this is the funny ones. Okay, this is in Australia. We leave stuff on the nature strip. So I was walking the dog one morning, and there's this washing machine. It's a smart washing machine, but if you look very carefully, you can actually see it's full of clothes. So this smart washing machine has locked someone's clothes into it, and they've actually got so disgusted that they've left it on the nature strip and they're throwing it away with their clothes inside. Well, that was funny. This isn't so funny. Last year, there was a NAPLAN glitch that left 40,000 students unable to complete their tests online. And the final one is actually very tragic. This, of course, is the MAX 787, I think it is. And that's an automation failure there. Well, essentially killed all the passengers and the crew in 2 aircraft. So that's an automation fail. So that's maybe a bit of a downer. I didn't really want to leave on a downer. But of course, we're actually focusing here on this thing, on this computerization and connectivity. That, remember, that it's a 2030 thing, that we can forget about full Industry 4.0. This will keep academics happy for years, I'm sure. I know it will. And this side here, though, this is where we're focusing on this very first stage. We're going to get 80%. In fact, like I say, those bars, I think, are completely the wrong way around. The visibility of processes and the predictive capability is quite straightforward to get once we look at computerization and connectivity. And so some acknowledgements to all the partners, capstone students. And I want to mention WIL students as well. That's work integrated learning. They are fundamental, I think. And if especially with small companies and having access to students that can work on simple projects like this, they're actually able to enable this very, very easily. And some thoughts. H.G. Wells didn't say this, but I think that digital thinking will one day be as necessary for efficient citizenship as the ability to read and write. And of course, the misquote is, it should say statistics. But of course, he didn't quite say that. But he did say something very, very similar. And of course, I said, don't forget your homework. So thank you. That's
so what is, Steve, what is the homework? Just to read that document?
It's to look at that document and to try and identify processes and products within your own organization that you would like to apply the smart enough sort of concept to. And what we'll be doing in the second workshop is looking at potentially a general, we'll go through, okay, maybe when you read this document, you'll find that it essentially breaks down, you know, that identification of your processes and products into a into a large multi-stage workshop activity over a number of hours. I want to condense that down because of this concept of opinionated software. I want to bring us to a point where we can use what they've provided and actually look at a potential example company in the middle workshop that can then be used to potentially inspire you to look at doing this in the third. And that's if we have any SMEs amongst us. And that's another thing. We'll tailor this. You know, if you're a solutions provider, or if you're an SME, or it's important to tailor this to the audience and to see what you want as audience. But the time is pretty much on 10:30 for me, and I think pretty much on 11:30 for you. But that's where we want to finish. So I'll stop sharing, and I think if we want to comment further until our time's up, that's it for my presentation. Thank you.
So Brian says that was amazing, thank you. And I can only reiterate that, Steve. A fantastic insight. Obviously a complex, potentially difficult subject, but I think you've really given us the tools that we need to start to understand it at least.
It's absolutely is a journey. It's not something that you can just go, hey, fantastic, I'm just going to plug it in now and off we'll go. It's very much driven by your business needs. You know, it's purely it. Machine learning. Look, that's really interesting. Those Arichan has asked to use machine learning in the factory in a box. We don't need to, because actually, if you look at the if you look at the process model, if you look at and sort of see when you're manufacturing something as a stream, it becomes something very trivial. It's just actually some very simple analysis to look at the model. So if you have a very simple production model, you can actually predict that very easily. And that's
Great,
it.
Steve. I should tell everybody that we did this in a hurry because it's your summer holiday just starting.
Yeah.
So basically, you're off for the whole of January. Lucky chap.
Yeah.
And,
the downer is we don't get 2 holidays. You see, with having Christmas and summer rolled into one, that's just one thing.
Yeah. So we wanted to get it in there quickly so that you know, so that at least we got started on this path. And Pamela will notify everybody of the date for the next one, and that will be sometime in early February. And then there will be a third one as well, because we've decided we should do that. So, and I'm thinking that will probably be towards the end of February, but we'll discuss that. But now we've got everybody's email. We'll keep everybody posted. We'll send that link out. And probably if there are any questions in the interim, people can either email me or Pamela or Swarav, and we can make you aware of that, Steve, if there are any questions.
Yeah.
So we're all starting together on the path towards Industry 4.0 or 4.0. I still think it'd be 4.0.
Well, look, yeah, I can tell you want to say 4.0, and we'll yeah.
But like you say, when you give a phone number, you go 1, 2, 3, you know, you don't say 0, 1. So
yeah, it'd be looked at funny, wouldn't you?
Works like that, yeah. Okay, and so everybody's thanking you.
Yeah, look, I appreciate. Thank you very much for your comments, everybody. I appreciate that. And some of the technical ones, I'm not sure on people's timing. I know you do have to move on, and I think that we're still recording at the moment. There are some questions that are actually fairly technical in terms of surface engineering sort of type comments. But the reality here is that the focus is actually on the business and the business use case, and that's why if you look at some of the applications that are done, they're very technical, and even Bosch is looking at retrofitting some old lathes, and it's looking at the RPM, it's looking at the belt stretching, it's looking at those belt slippage. You know, if you're actually a manufacturer, you want to know how many widgets it's made. That's it. That's the money making side of it, and that's, I think, I know it sounds quite well, what's the sort of the right term to say it, but quite crude. But really, that's the issue for companies to stay in business, is what they're really looking for, and they don't have the luxury of spending, even thousands of dollars on things that are just icing on the cake. It's really focused on productivity. And I think that's the bit we need to take out of this. And of course, but moving on, once those things are in place, it starts to become easier to actually become informed about how you're going to actually invest further in these technologies and maybe look at those enhanced systems where you're looking at sort of the AI, looking at sort of the bigger or the nicer tools that might be available to you. But yes, you've got to start somewhere.
Tremendous.
All right.
Yeah, I think we can call that a day. And thanks very much again, Steve. Really appreciate that. I like
okay.
Daniel's comment there, a good, honest presentation. And, you know.
Trying to be.
Yeah.
You know where I live, you see. That's the problem, you see.
Yeah.
Yeah. So yeah, I think that's it. Yeah, I can't actually sort of say that in the combination technologies. I think those things are sort of slightly outside of my remit there. But yeah, that's obviously important. So yeah, I think that's it. I think there's in fact we got Andrew who's actually in Australia as well. Hi, Andrew. Yeah, and a few people actually as well. There's someone in the Netherlands as well. It's nice to see that it's not just going out to the UK, that it's a fairly international group that are interested. Andrew's, yeah, I think we've tried that controller. We've tried to answer, or I'll try and answer that, if not in here, because of course it was just a taster, in the following sort of lectures, what we can do, or what's possible to do with low cost. And we're talking, look, it was a bit like coatings, Alan. I think I remember that aim of getting coatings down to sort of, was it 5 pence or 5 cents for a tool, you know? And this is the idea. We're looking at orders of magnitude. We want to sort of knock off the zeros. We're not going to get it down to the $1, you know, and we're not at the $10 yet, but we're down at we're less than $100 per sort of machine, you know, but we'd like to get down to that 10. But of course it becomes a commodity then, and who's going to sell them? So that's why it's important that it's that the time or the ability to apply this is actually something that becomes built into SMEs or to the manufacturers, because that's the only way that we can get that and achieve that low cost. That's how that jelly gets nailed on the wall. We do have to change the jelly. I hope you like that. It tickled me anyway. All right.
Great stuff.
Okay.
Okay, thanks very much to everyone.
Thank you very much.
And we'll see you again in February. Have a nice Christmas. Try not to catch the virus.
Absolutely. Everyone stay safe, and nice to sort of see you all. Okay, I'm going to leave.
Yeah.
Thank you so much for joining.
Thanks a lot.
Bye.
Bye.
Happy Christmas.
Yeah. Thank you. Thanks, Steve.
Goodbye.